Whoa, everything's going nuts.
Hello everybody. There's some code up there. I'm going to type a bunch of code in Emacs because that's what people do when they're doing talks with independent type stuff. Right, so I import the vect library and then I say that it should make things total. No, just kidding, this is actually slides. My picture's too big though. Yeah, so obviously this isn't Haskell code, so thanks for letting me be here, but I think of Haskell sometimes, or its interest as being something like a dialect of Haskell or a child of Haskell, so I hope it's okay.
You have the speaker. You have to be a speaker on your laptop.
Yeah, of course I do. I write a lot of Haskell code. Okay, another way that you can see what I'm going to show you is some nifty experiments in Haskell-y syntax that Edwin Brady has done, because we were mentioning them earlier and maybe not always understanding them, and I think some of them would be awesome if they made it into some language pragma thingy-majig. So another way we could see this is that it's things that you can steal from Idris, which may be profitable if you want them. So the first is idiom brackets, which was not invented by Edwin, but rather by those who invented applicative, McBride and anyways, if I take a look at read int here, this is something that's going to give me back an IO of int. Cast is a horrible hack we have in the library that just converts some types. And I want to see like what does this actually mean? So I look it up and I see that it's right what we'd expect, right? This is a nice syntax. As do notation is the natural way to write monadic stuff. Perhaps idiom brackets are the natural way to write applicative stuff, and maybe we want those in Haskell. Another thing I can do with idiom brackets is translate this horrible thing into this nice looking thing here. And it ends up meaning the same thing, but now we're using applicative operations instead of monad ones, without having to have some sort of like weird intentional thing that makes return kind of sort of a keyword. Sorry. Other things I can do with idiom brackets, once I've scaled my font to make them look nice, is I can sort of stick them around stuff. Yeah, bingo, yeah. 5 in a row, vect. And so now I've got this IO program here, and look at here, no idiom brackets. That's because idiom brackets are completely unsuited to when we have dependencies between different things, right? But there's also no weird do stuff. Like this just looks kind of like an ML program, except I've got a little bang saying, run this thing for me, and have some effects. So what does that little bang thing mean? Well, let's take a look. This bang thing really looks a lot like things you already know. Once I scale my font a bit, what is going on here? Okay, there we go. So what it's doing is it's reading the nat, then it's sending that onward, and reading that many ints, and sending that onward, and then it's going to print out the sum. And just to show that I'm not entirely pulling your leg here, I can try something like running at some numbers, and let's sit here, and sit here. Then I tell it how many numbers I want to add, let's say 4, and I give it a number, 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 and it's added 4 numbers for me. So I can actually, run this thing. Whoa. Another thing that I think is kind of nice is, as opposed to like monad fail, is that sometimes I might want to fail in a couple of different ways. So let's say I've got this notion of a size error, which is that something can be too big or too small. And a little function here called Goldilocks, which checks if a string is too big, too small, or just right. So we're going to say the string is too small if it's less than 4 in length, and it's too big if it's greater than 6 in length, otherwise it's just right. So I can write a program here, and covering is something which says to Idris, like, don't allow me to write this if I'm missing any pattern cases, but non-termination is acceptable. And so I put a string, and saying which string. I then read in a string and Goldilocks it. This looks a lot like Haskell, but then I've got this funky little vertical bar here where I've got some more patterns that I can match. And if it's too small, then I can say that and then continue and ask for another string. If it's too big, I can say that and then ask for another thing. But if my pattern matched, which is to say if the right constructor was invoked, then I can say the string is just fine and finish up. And if I run this,
It's like a funny case with the left and the right, the two branches of the case, and the rest is the last branch.
yes.
Okay, so sort of one distinguished big branch.
Yeah, so I mean, it's a common thing that you've got the result you care about and then the things you have to deal with that may be wrong.
Oh, yeah.
And this is a sort of a nice little extension of denotation for encoding that, and I'm out of time, or I would dump the desugaring, but I can show you after if you want. Thanks.